Hi there, and welcome to part 4 of our sentence instancing tutorial series. We probably had to place this tutorial somewhere in between part 1 and 2, so we might call this tutorial part 1.5. The reason why this one had to be recorded earlier is because several people couldn't follow along this series because they've stumbled upon an error when trying to texture instancing function. This error sometimes comes up with older graphics cards, non-Kepler architecture-based cards, and we've had some examples, mainly from Mac OSX users, where it just says instancing texturing is not supported in this OS. Fortunately, there's a workaround, and it's not extremely difficult to set it up. This workaround opens up a lot of new possibilities for future tutorials. So for the sake of continuity, let's name it part 4 then. Now without further ado, let's get started. So this is where we've left off. I'm gonna play the timeline. You see that our shape is still working, but some of our users are experiencing errors because of the texture instancing function isn't available. And the key solution for a workaround is replicating geometry per character. That sounds a bit heavy, but I will show you that it's not heavy at all. So the first thing we're going to do is we're going to borrow this part and I'm going to cut it. I'm going to make a new base container. Call this one Non-Kepler. Start with a replicator and a new base container. We are going to replicate. Call this one instance 0. So that will be the first one. Instance master operator is instance 0. Gonna paste this. Paste this geometry section in here. So now we're going to replicate this one based on all the characters and let the render pick every geometry component from here. So the first thing we're going to do is get the data from the convert job in here. So that will be the null 3. I think I already gave this one an op shortcut. Yes, I called it main. So this comes in handy. Select job. Select main. Null 3. Set it to expression mode. And there it is. The key solution lies in sorting this select job from the first character to the last, so you get some kind of stairway shape. So I'm putting a sort behind this one. Let's look at the first one. And you see that by sorting these ASCII values as the leading channel, you see that this section only refers to the first ASCII value. I think that it's 32. And 32, if I'm not mistaken, let's have a look here, is the empty one. So that will be the space. So there are a bunch of spaces. And this is probably couple of small special characters like a comma or a question mark or whatever is in this sentence. And what we need to do, we need to isolate all these small steps for every instance separately. I'm going to show you how that works. Let's get back inside of the instance base, the first instance, instance 0. I'm going to put a trim behind here, trim. You've probably noticed there is a second input in here. And here you can feed in the begin and the end point of the section that needs to be isolated. I'm going to do that with a pattern. It's going to be a simple constant, leave it at 1. So if I'm going to input this one now in here, it's going to isolate the first sample up until the 1000th sample. And we only have 134 samples here, so this is not working. And let's see. So I have to tell this pattern the beginning and the end point of the section that needs to be trimmed. So I'm going to trim this pattern again. And I'm just going to give this one sample. And by trimming this one, you can stretch your selection up, the start and the end point. So this section is going from 4 to 9. And if I'm going to input it in here, you see it's going to isolate samples 4 up until 9. But how does this trim job know where to start and to end? That's a different story. And for that we have to get back to the replicator table. And we need to augment this with a couple of extra columns. And the first one is how many times is a character showing up in this sentence. So we know how long the trim section is actually going to be. So we start with a selection of the characters. Oh, wrong script. Select the second column. These are the characters. I'm going to put an evaluate behind it. I'm going to put in a nifty expression in here that's basically counting the amount of characters are showing up in this sentence. So first of all, we're going to look at this field, and then we have to get back to the UI. So that's going to be this one, this cell. Already gave this one a glow up. Shortcut yes, field. So it's going to be a string. So string op field op no one and was the first cell, like this, dot, count, string, me dot input cell. Input cell refers to every cell in this select that. So if you put this one into expression, we get an error. Let's see what happens. I think I forgot. Oh yeah, forgot this one. So you see that the space is showing up 47 times, the comma 1, the dot twice, capital A twice, etc. So this is the first part. So I'm going to put a merge in here. Merge like this. The second column we are going to put in here is the beginning of the selection, and that's basically the sum. The next one will be the sum of the last one. So the space will start at 0 and end at 47. The comma will start at 48 and end at 49. The dot start at 50, etc., etc. So we have to put in a small script. I'm going to make a new base container. Call this one cumulative. Don't know if it's actually an English word, but it makes sense to me. Select the eval, let's see, 3. Eval 3. Set to expression. It's actually the wrong select. I need a select that. Eval 3. Okay. And our script. No, text, yes. Going to make a clean table. Going to use an external library who has a cumulative function. It's from NumPy, so I'm going to import it first. NumPy, py, give it a shortcut SNP. Going to fill the table. And as always, I'm going to clear it first, otherwise it's going to fill up very easily every time we put in a new sentence. Well, just take R. We're going to look at the select one, entire column, first one, and this R is going to be cumulative summed up, R. And now we're going to use a for loop. So for x in R, now our clean table, 1, append a row with X. So in short, this script is looking at this table, and every row is going to calculate all the cells before. So if you're going to run this one, we get an error. Okay, let's see what happened. Clear, there's no attribute clear. Oh yeah, I forgot this one. Okay, so you see, like I mentioned earlier, this one is 47. Next one is 47 plus that, 48. So 48 plus 2, 50, and so on and so on. So this is basically the starting point for every trimmed section. And the amount of every character is summed up with this beginning point. So you automatically get the end point of the trimmed section. So I'm going to show you how that works. Put a null in here and then out. Going to merge it in here. Set this one to append columns. So now we have the ASCII value, the integer of our replicated characters, the actual characters, the amount of characters showing up in the sentence, basically the frequency, and this is the begin point of our trimmed section. So now we're going back to our Non-Kepler instance. In here I'm going to borrow the replicated table in our main section. Main, if I'm not mistaken, this one was called replicator. Yep. Okay, let's select that. I'm going to pick the frequency first. So select 2, select columns by index, the third, and the other one fourth. So this is the amount or the frequency, let's call it frequency. And this is the table with the beginning of the trimmed selection. Call this one start. And the thing is, it doesn't begin at 47, it begins at 0, so we'll use an insert. Before first, it's going to be null. Okay. So now we're going to fill in these values. We're going to use the digits of this replicated base container and looking at this select, or this rather. So let's see what happens. So start. The first one, start. So up, start. And with every table we have to give it a row and a column. So me.parent dot digits. So that would be the 0, so the first row, first column, close it with a bracket. So that is working. And now we fill in the frequency. Here we're going to sum it with the start point. So me.par.start plus op frequency. Again, me.parent digits 0. So let's see what happens. You see that the null is also calculated within the section. So you, for the space, you have 48 samples. And that's not right, because it comes up 47 times. And we can fix that by just put a -1 in here. And there it is. So this section gets trimmed based on this data, the starting points and the frequency. And this trimmed section is going to be fed in here, and it's isolating this first 47 samples of this overall container. So it's isolating this one in here. And then it's just basically basic instancing stuff. Moved it a little bit aside. Closed it with a null instance. Null1. Don't think we need a scale for now, but leave it there. So now you see that this space character gets replicated, or this geometry is getting replicated at the positions where it needs to be. So now we're going to feed in the replicator table, or the replicator component. So we're going to look at replicated by number, and the number of replicants will be the main op replicator num rows, and we won't need the first one because We've already set it up in here, so make sure you put a -1 in here. Otherwise, it's going to show up twice, and that's not something we need. So, if you take a closer look at, well, let's see. If you take the capital A, so that would be instance 3. Instance 3. You see that it gets trimmed. Starting point 50, the end 51. So it's only 2 samples, so it's probably only showing up twice in this sentence. And you see that it's at the right positions where it needs to be. But these are still rectangles, so we somehow have to feed in this font with the right data. So we're going to look at the color map. I believe it's the color map. We have to feed in the font with the right color map. And the color map is something we've already created with this character replicator container. So let's get back. Going to this one because this is the main one. If you're going to change stuff in here, and when this replicator resets, you lose all your adjustments, so do it in the main one. Going to the color map, and let's see if I gave this one an opt shortcut. I'm not exactly sure. It's called characters. And this one needs a path. So we're going to fill in a string. I think I'm going to do it the old-fashioned way. So upper level, characters. The containers or the tops were called text. And every instance has to look at its parent, so plus me.parent dot digits. Set it to expression. So now you see this one is going to look at text 0. So if you go back, characters, text 0 is the space, so this is the empty one. It seems like it's working. Let's recreate all the operators. Have a look at this one. And now you see that it has the A at its right position. This one is the L. Let's see if we can find a character that it's showing up a bunch of times. The letter E. So that would be instance 8. Let's have a look. Instance 8. All E's at the right position. So now we need our render top to look at every geometry in every instance. So non-Kepler container instance asterisk sign geo1. And there it is again. So this is the workaround. This one isn't yeah, it's already working. Nice. This one is working as well. So if we have a look at our instancing data, you see that every instance is also looking at the text size. So this is already working. Color invert is working. Rotation. Geo size. For every text separately. So this is basically it. If we're going through all the different animation shapes we've created in the last tutorial, this one is working. And if you take a closer look at this one, you see that there are duplicates showing up. And with this one it's even worse. And the reason for that is that if we take a closer look at our convert section and to our output table, which feeds into the instancing data, see this section is empty. And that's because of the nature of the grid and the way we set it up, the number of the rows and the columns. If you go to our first one, you see that this table is lining up nicely, and that's because of the mathematics of this shape. It's calculated by the exact length of the sentence. So this table is filled up entirely. And with the grid example, you see that we miss 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 spots. And that's because the grid is calculated in a different way. So if you take a closer look, we have 144 primitives, and this snake pattern has 134 patterns or samples. So we see we miss 10 characters in our grid example. So we somehow need to append this table with a couple of extra spaces. Because now if we take a closer look at our replicated geometry, and the first one, the space, you see that if we sort it, this first section are exactly the 10 spots we've missed, and this longer one is the amount of spaces with the ASCII value 32. And you see if we trim the section, this one isn't lining up anymore. So the whole lining up front in all the instances gets messed up. And that's why you get all these duplicates. And in order to fix that, we have to get back to our string convert. And we need to append this table with a couple of extra spaces. So what we're going to do, I'm going to have a closer look at the length of this one and the length of this one. We subtract it and then we probably end up with the exact amount of characters we missed. So I think I'm just going to use a simple constant. Call this one append row. Going to close look at this one. Minus the first one because that's the name of the column. So up, null one, num rows, minus 1, 144. Put this one in parentheses, minus op table 1, this one, num calls. So we're subtracting these two, and you see that what's left is the exact amount of rows we need to append in here. And in order to do that, we're just making this one 10 columns longer. Let me just take another table. Exact dimensions, 1 row, 10 columns. I'm going to fill in a space character in every one because now it's just empty. I'm going to set this one aside a little bit. We use an eval for that. Expression, just a space, like that. Put a merge in here. Merge, like this. Put this one in here. Set to append columns. And you see now this one has 144 as well. And let's have a closer look here. See now this table is filled correctly. But you're still seeing the duplicates in here. And that's because we have to change this one as well. And this script is looking, or this one rather, is still looking at the input field, and that's this one. And this one has a different amount of characters than these columns. So what we need to do is, if we go take a closer look in here, you see this is just one cell with a couple of spaces. And we need to make some sort of exactly the same cell, but then based on this data. So I'm going to take a select in here. Going to pick the merge 5. It's this one. Going to convert this one to text. Delete this one. Text. delete. There it is. And if we convert it back to a table again, you see now that it's fitting inside a cell, just like with this field. But now it's calculated based on the amount of primitives of the grid. So if we put the null 3 in here, null 3, you see immediately it put the 10 extra rows on top of this one. So that is working. But now we have to update this cumulative script. So if I'm going to run this one now, you see that it freezed for a second, but now the grid is lining up nicely. And the thing is that we need to run this script every time when we switch from the shape, because now you see there are still duplicates here. You see that it's changing over here. This is the snake one with the exact amount. For the noise, the same thing, because it's calculated based on the amount of characters this sentence has. So it's not hard-coded, and this is sort of hard-coded, but we fixed it over here. But now you see that this one isn't working now, so if we run this one again, there it is. So we somehow need to run this script every time we switch animation shapes. So we're going to our UI. Going to put one in here as well, just to be sure. First, give this one a global op shortcut. Cumulative, nice word. So op, cumulative, op, script, run. And the same thing for the switch. Up here. Cumulative op switch dot run. So now if we take a closer look in here or in here, you see that now, in this particular example, the shape has less primitives than the actual sentence, so this whole shape isn't working at all. Take a close look in here, see 102, so that's what I've mentioned in the earlier tutorials. The downside is that this shape is fixed, so always be sure that you're making a sentence shorter. We can test it. Let's delete this section, press go. See, now it's working the right way. 48, 48, couple of spaces extra. Let's see, copy this one a couple of times. See, it's updating. I think this is working as well. No, there's still some kind of error. Let's see, 66. Somehow this one isn't updating yet. Let's run it. There it is. Somehow this switch isn't running the script. Cumulative. Don't have any errors. This one is called script. Okay, there's an error in here. Switch. Cumulative. Run. What did I do wrong here? Cumulative. Did I misspelled something? Cumulative. Yes. Script. Okay, that's weird. Object has no attribute run. Well, it has, so. Switch. Well, this one is exactly the same, so let's see if we just copy this one. Okay, let's have a look again. Okay, great. Now you see it's updating. Don't know exactly what happened here, but somehow it's now working. So that's basically it. Close this one. Back in here. Hopefully we've made a couple of users very happy with this workaround and give all the non-Kepler users also the opportunity to work with this interesting ways of generating kinetic typography. I've tested this patch on my old HP laptop with some kind of, I don't know, internal graphics card, and it's working just fine. As always, thanks for all the support so far. Please like and subscribe to stay up to date. It provides us a lot of extra motivation. Stay safe, happy texting, and we'll catch up next time.